I think we can go ahead and get started now. And I want to first thank everybody. First to thank ANS for being such a great partner and putting in so much effort to help make this workshop successful. I want to thank all of our panelists and speakers for agreeing to join and participate in this workshop. I believe we're at over 30 speakers and panelists. Also want to thank all of the attendees for joining this workshop. It has always been intended that we have participation from the attendees, even if you don't have a formal speaking role. The value in a workshop is to get all of the perspectives out there to brainstorm and sort of zero in on path forwards and solutions to the issues that are being discussed. And so that'll be important. For the topic itself, advanced reactor codes and standards, this is an area that's very important to the development and success of advanced reactors. While there's been discussion and some limited interaction and development of path forwards in this area, we feel that it's the right time to really begin a concerted effort to address this area. A couple of things which will be discussed today. First, ANS had a report on this topic, and that was followed soon after by an NEI report, and we'll talk through what those reports said and talked about. We also know that the standards organizations and the NRC and DOE are also interested in this topic. And so there's a lot to discuss here. And we'll hear from the speakers themselves on why advanced reactor codes and standards are so important and what the next steps might be. The desired outcome for this workshop is to identify what is the path forward so that the codes and standards can be a productive part of making advanced reactors successful and not something that slows down or impedes progress. And so we'll be successful if we identify the next steps to move forward in that direction. With that, I'll turn it to you, John, for your opening remarks.
Yeah, thanks, Mark. Good morning, everyone. For those of you who don't know me, my name is John Starkey. I currently handle government relations activities for ANS. And on behalf of ANS, I welcome you all to today's virtual workshop. It is my hope that today's discussions help us inch closer to creating a path forward for the development of standards across all SDOs in order to better support the exciting advanced reactor technologies of today. Before I kick things off and get into logistics, I first want to recognize ANS Standards Manager Pat Schrader. Pat has done a remarkable job in getting today's panels aligned, speakers invited, and darn near most everything else. So we would not be holding this workshop nor be having these important discussions throughout today if it weren't for Pat and the time she spent putting this together. So thank you, Pat. I also would like to thank Stephen Arndt for his leadership and help, as well as NEI's Mike Schultz and of course Mark Nickel, who we just heard from. Now I'll briefly cover some logistics for today's Zoom video workshop. First off, everyone will be muted throughout the day, except for obviously the individuals presenting during their specific panel sessions. Moderators will open each panel discussion with a brief explanation of what their specific panel will be covering, along with brief introductions of panelists, and then panelists will give their topical presentations. Once all panelists have presented, we will then move to a Q&A session for the final 15 to 20 minutes or so of each panel. Moderators may have a few pre-drafted questions for their panelists. However, I believe most of the Q&A time will be allotted for the audience. So please do use the Q&A function at the bottom of your screen to type and log any questions you have. Moderators will try to get to questions in the order that they are received, as well as sort through any duplicate questions while also working to keep the conversations on track with specific panel objectives. And I know that any questions that might go unanswered will be recorded and responses will be worked on offline and sent back to the question sender in a timely fashion. And before we get to the actual panel discussions and perspectives from both DOE and the NRC, I'd like to first introduce Mr. Stephen Arndt, who on behalf of ANS will be giving a short presentation on the 2019 ANS Special Report on Consensus Codes and Standards. Stephen will then be followed by Mr. Mike Schultz, who on behalf of NEI will be presenting the NEI Advanced Reactor Codes and Standards Needs Assessment Report. So with that, Stephen, the floor is yours.
Thank you. As we just mentioned, I'm going to give a short review, if I can make everything work properly, of the if I can get this working. Okay. Of the American Nuclear Society Special Committee on Advanced Reactor Policy Report on Standards. And the purpose of this report was basically to discuss all of the key issues associated with standards as it has to do with advanced reactor policy. The committee itself was formed by ANS President John Kelly at the time, and it looked at a number of key legislative, policy, and implementation issues and recommendations that existed at the time for advanced reactors. And we determined that our first product should be a report specifically on advanced reactor standards. ANS standards have always been part of our core mission as a standards development body and as a technical society. So we put together a very impressive group of people. The list is on this slide here, but people like Bob Budnitz, who's been in this business for years, Mike Corradini, George Flanagan, Mike Schultz and myself, lots of people who really understand not only how advanced reactors work, what the needs of the industry are, but also how standards fit in. So in general, what we were trying to do is understand the essence of particular issues that can support what is happening in the advanced reactor policy area as well as the advanced reactor issues. So what we wanted to have is details of the activities associated with advanced reactor standards and the essence of all the potential challenges and solutions associated with all the stakeholders. Because standards are such a key issue, we wanted to get at what were the challenges, the policy challenges and the technical challenges that are keeping the U.S. from being the leader that it can be. Historically, the standards have played a key role in designing, licensing, and operating light water reactors, and we think they can play a key role in advanced reactor standards. They can facilitate the technical margins that are appropriate. They can work with the reactor suppliers to get out a marketable advanced reactor standard. One of the key issues we discussed was how do you use standards not just to develop a good licensing basis and a good design process, but also to show to the world that what we are doing in our designs meet the highest quality standards, and to help the suppliers demonstrate to the market that they can reduce the risk associated with first-of-the-kind implementation challenges.
Hey, Stephen, this is Pat. Did you want to share your presentation?
I thought I had. Hold on a second.
There we go.
Thank you. Does that have it?
Yes, not in full view, but we do see your presentation.
How about now?
There we go. Perfect.
Thank you.
Sorry. Some of the challenges that we've seen and that we articulated in the report included the time constraints required to develop the standards, the impact on project schedules, and in some cases, the resources that may or may not be available to advanced reactor developers. Also of key importance is the information necessary to support standards. One way to mitigate this is through the use of performance-based standards, which we highly recommend, and in ANS, we actually have a subcommittee of the standards boards that looks specifically at how to make standards performance-based. In addition to the challenges, we have a number of opportunities. We looked at what are the key potential strategic standards in a ANS-NRC workshop in the spring of 2018. As was mentioned in the introduction, NEI has looked at where the standards needs are and what the most important issues are. And we've looked at a number of studies that have been done. The one that's quoted in the slide is associated with an MIT study that was done a few years ago that found significant projects costs can be achieved if we can do this correctly. The ANS standards workshop identified a number of key standards, and the 5 listed here were some of the ones that were identified as part of that workshop. The risk standard for advanced non-light water reactors was an extremely important one. There are several ANS standards that look specifically at advanced reactor standards, the ACI standard associated with safety-related concrete, and there are a number of other standards associated with the various technical disciplines necessary to effectively implement ANS advanced reactor implementation and licensing. NEI also found similar results in their report that I'm sure will be discussed shortly. In developing the report, we decided that we needed a set of recommendations for future action. And these were high-level specific recommendations that were developed for specific stakeholders to move the process forward. The first recommendation was for Congress to authorize the accelerated development through funding through the DOE of advanced reactors. That would include accelerated development and updating of key standards. The second recommendation was for DOE, in coordination with the SDOs, to solicit input for advanced reactor developers, non-governmental organizations, other key stakeholders, to know what the right standards are and the timeframes associated with that. We hope that this workshop will provide a key input associated with that recommendation. The third recommendation had to do with providing incentives to the national labs to proactively participate in gathering the new data and methods necessary to support the standards, and also to work with the SDOs to support standards development. The fourth recommendation was for NRC to get in the process as well and timely adopt the advanced reactor standards that will be developed. And they should also look at the margins imposed in excess of an endorsed standard. Key issue. And the last recommendation was for the DOE and NRC to look at a formal process for achieving a harmonization in safety margins. Make sure that we're not adding margin on margin when we're using multiple standards in a process. Where we think we should be going as a follow-up to the recommendations associated with our report is to work with DOE to develop formal methods to assist the SDOs and the advanced reactor developers in conducting the accelerated development of the standards. And this could be through a funding opportunity, such as GAIN or some other funding opportunity. It could be through providing additional resources to the laboratories or a number of other efforts. The second follow-up would be to work with the SDOs to encourage input and resources on identifying the highest priority standards. Again, NEI has done this, we've done it, we've got a pretty good list, but we really need to nail that down and work on it in a priority fashion. And to work with the SDOs and the other stakeholders on those standards. With that, I will conclude my remarks, and I think, John, we may have time for a little bit of questions.
Yeah, if anyone did have questions after Stephen's presentation, please do use the Q&A function at the bottom of the screen. Okay, so we're starting to get a few funnel in. We'll keep this brief because I want to keep us on track with the agenda. So first question I see here, Stephen, what will be the role of IEC?
Well, for those of you familiar with IEC, that's the International Electrotechnical Congress. That's the international equivalent of IEEE. And although IEEE and ASME and ANS are international standards, there are also international standards bodies like IEC, and all the international standards bodies need to play as well as the US standards bodies. In most cases, we can gather their input to our IEEE friends for IEC because they have a collaborative relationship, but we have other standards bodies that are separate, like the Japanese version of ASME and others. And we need to reach out to them as well, because if we're going to develop this advanced reactors and market to outside the US, we need to make sure that we are looking at those standards as well. So even though we may be focused on the US standards because we're focused on the US community, we also have to take into account all of the international standards bodies and their efforts to try and harmonize with US standards, but also in some cases, the development of those standards that are going to be broader and that may or may not be as performance-based as our standards.
Thanks, Stephen. Let's move along, and I'll introduce Mike Schultz to give his presentation.
Okay, and I can answer some of these questions offline.
Great, thanks, Stephen.
Okay, good morning to everyone. My name is Mike Schultz. I'm a consultant to NEI, and I'm trying to get my slideshow to share here.
You're good.
Okay, great, thank you. So NEI, basically starting 2 years ago, was looking at what it needed to do to bring the advanced reactor community together with the standards organizations. And we saw that, you know, there had been a number of workshops over the past several years, and you know, the workshops would come and go, and despite the efforts of everyone, we seemed to be stuck in kind of the same spot. And so we were trying to identify areas where we could try to bring the advanced reactor community together with this codes and standards community. So that was the initial idea behind this report, to help bring those communities together and identify a path forward. We started working on a report. The report is NEI 1903. On the slide there, it shows you the link to an NEI website that can be accessed by anyone. You don't have to be a member of NEI. We wanted to make it publicly available so as many people that got access to it and could read it as possible to get the maximum benefit out of the report. The other thing that I would like to say at the onset about this report is we wanted it to be a push, not a pull. And what I mean by that is we wanted it to reflect more of the viewpoint of the advanced reactor developers than the codes and standards organizations. So because of that, we specifically did not have outreach to codes and standards organizations to develop this report. We did a survey of advanced reactor developers. Quite honestly, the survey results were pretty scattered. There was not a common thread of what was most important. And I think part of that reflects the diversity of the designs and the technologies in the advanced reactor communities, so that you know, it's hard to gain a clear view of the future, because there's no winners and losers at this point. There's just a number of different technologies that are out there being pursued. So that kind of helps blur the future for us a little bit more. So we attempted to build on the activities that had been done before on this topic. Oak Ridge National Laboratory had issued a report. I think that it identified hundreds of different standards that needed to be worked on or revised or developed. And both ANS and the Nuclear Regulatory Commission had identified technical areas that warrant additional research and development to support standards. So we were trying to build off of those prior efforts. And what we did, the main outcome of the report, is we provided a list of standards which we prioritized that we felt would be most important in the near term for supporting the deployment of advanced reactors. So as a part of that process, we identified 18 codes and standards that we evaluated to be high priority. And I'm not going to go over them specifically in this presentation. They're in the report in a table. We kind of provide some justification of why we think that's important in the table. One of the things that was a challenge for us in developing the report was, how were we going to prioritize codes and standards? And so we developed a set of criteria that we use to score and rank the different standards. The criteria there are supporting design efforts, supporting licensing reviews, reducing component fabrication time and costs, reducing facility construction time and costs, and reducing O&M costs. And so those were the things that we were looking at to try to evaluate the different standards to see which would be most beneficial. And we put a weighting on standards that were of benefit early on in the process to support design and licensing. And the reason we did that was because if you can't get past that first phase, then the other phases become less important. So you can see the criteria we have there for designating standards as codes and standards as high priority, medium priority, and low priority. So, you know, one of the things, you know, that became apparent is accelerating development is extremely difficult. And one of the reasons it is so difficult is it requires collaboration across so many different organizations. There doesn't appear to be a process or criteria that is common amongst those organizations to figure out what would be most important, what should be pursued first. And last of all, there doesn't seem to be specific funding for these activities that would allow them to be accelerated. And, you know, one of I think the most important findings of the report was that we need to develop some kind of process beyond forums and workshops that can get everybody on the same page with where we need to go, what needs to be done in the near term, and then develop some kind of process for cost share with developers, or Steve might have mentioned in his presentation, potentially using GAIN for those types of awards for funding codes and standards developments. But something needs to be done to bring people together, get a common vision of what needs to be worked on, and then lastly, shorten the time frame. I think one of the things that developers see as a challenge for codes and standards development is the time frame needed to from the identification of the need to the endorsement of the standard is so long. It's out of their horizon of what they're looking at to design and license their specific technology. Although I think codes and standards organizations are capable of accelerating efforts and have shown that they can do that, but overall it was seen as a challenge. So that is my slideshow in a nutshell, and I guess we're right on time. I don't know whether we want to field any questions or just save them for the next session. I think the best thing to do would be to just continue on, and I will introduce Dirk Cairns Gallimore from DOE Office of Nuclear Energy.
I believe he is going to have to call in. He was having some problems with his audio. So hopefully he does that momentarily.
Good morning. Can you guys hear me?
We can.
Perfectly.
That's excellent. Thank you. All right, so let me get set up here real quick, and we'll get started. So yes, my name is Dirk Herons-Gallimore. I am with the Office of Nuclear Energy. I think this is a very interesting experience for me in one respect, is that as a little bit of background is I joined the Office of Nuclear Energy in this particular area back just in October. Prior to that, I spent a year on a detail to the Coast Guard helping them with their enterprise risk management structure. And just prior to that, I was with the Nuclear Energy's Office of Space and Defense Power Systems and the lead and program manager for the multi-mission radioisotope thermoelectric generator. That's the generator that was on the Mars Science Laboratory rover and is also going to be on the rover for Mars 2020 launching this summer. So I have an appreciation of what it means to build something, get in and getting it deployed. So with that background, let's kind of slide into the presentation here. So I work in the Office of Reactor Fleet and Advanced Reactor Deployment. The goal here is for us to be a catalyst for the commercialization of our research and our development and our demonstration projects. And we want to integrate this research to achieve, a balanced portfolio internally and do a lot of cross-cutting research through, our various GAIN initiatives, our IFO and our FOA. So we want this to fully and effectively integrate our R&D and our planning and our execution and our oversight. We see this a systematic management of our investments and our research capabilities, and we want to align our R&D programs with the industry-identified technical and regulatory needs, and then accelerate these innovations and get them into the marketplace. What it means for me, and in my role within the office, as we'll see a little bit more shortly here in a moment, is that—
Excuse me, Dirk?
Yeah.
Could you put your presentation in a full slideshow view? Right now we're seeing your notes.
Oh, okay.
I just thought you'd like to hide those for yourself. Eileen, if you have any helpful hints you want to share on that.
Sure, you should be able to go to the top where it says display settings.
There it is. Got it.
And on the left, yeah.
Thank you.
Is that better?
Perfect, thank you.
Great, awesome. So this is the organizational structure for the Office of Nuclear Energy, and specifically for the office that I work for. It's under our director of Alice Caponiti, who I've worked for with many years. We have two divisions. One is the Office of Nuclear Energy Technologies, and the other is of reactor deployment. I have duties in both sides of this. For this activity, it's where I'm under the National Laboratory Industry Capabilities team, and this is our cross-cutting team. And so this deals with a lot of our advanced manufacturing, a lot of our ways we fund folks. And so specifically, I have both the duties of being our POC for codes and standards, and I'm also our technical lead here at headquarters for our advanced manufacturing capabilities. So we have these two divisions. We got our reactor deployment area, which is advanced small reactors and advanced reactor technology, microreactors, light water reactor sustainability, and more recently, as we'll see in a slide, is the advanced reactor demonstration program, which I think has advantages for what we were talking about at this point. The other office is our nuclear energy technologies, and we have got our cross-cutting technologies area, which is advanced sensors and instrumentation, advanced methods for manufacturing, integration of energy systems, and cybersecurity. All of these areas have implications on our codes and standards. And internally, we do our best to coordinate between the various different groups. But this is also always a challenge, as you can imagine, with the different polls and different requirements and different priorities based on our user needs for both the current reactor fleet sustainability and the various different advanced reactors that we're looking at. This also runs the the Nuclear Science User Facilities, which is where you see our CNR and some of our GAIN initiatives run through as well. We do the advanced modeling and simulation, which has another group which has advantages for us if we leverage them appropriately. And then we have a demonstration that DOE has been heading up, which is the Transformational Challenge Reactor. So right now we see that over 60 companies and research institutions are working on advanced nuclear reactor projects for a wide array of capabilities to meet energy future. You know, we got sodium, gas, you know, lead, molten cold reactors. You know, these are different from what we've traditionally seen of the standard light water reactors. Even though, you know, some of these capabilities were demonstrated many, many years ago, but they are now coming back into their own, and we see an advancement as we go forward. You know, we see potential safety improvements. There's various options for future commercial, you know, for civilian uses, you know, limited grid military applications, improved resource utilization and waste reduction, and flexible operations to support, you know, our national grid and containing energy resource applications. And of course, we're looking also at how do we take the advanced manufacturing or modeling techniques and bring those not just into the 21st century, but how we can further those and make sure that they get used within our manufacturing capabilities, just not for the United States, but also to make us more competitive on the international market. And then more recently, you know, Congress directed us to initiate the Advanced Reactor Demonstration Program. Our initial funding this year is roughly $230 million, and it's to establish the program and to get it up and running. And the goal for this, there are several goals. The main one is that Congress wants to see the construction of 2 demonstration reactors that are operational within 5 to 7 years. There's an active solicitation on the street right now. I encourage you guys to visit the Idaho National Lab, the Department of Energy's Idaho Operations Office website to get more information on that solicitation. That solicitation actually closes in August, and we are going to be underway to move forward on that program. So the goal of that program is to focus both DOE and non-federal resources on the construction of real demonstration reactors and the supporting activities for commercial use. This does include things like codes and standards, because we know that those are going to be very important moving forward for not just these demonstration reactors, but for the future commercial efforts. Congress funded it to establish the program to demonstrate multiple advanced reactor designs. We've tried to write this so that we are technology agnostic. We don't necessarily care what the technology is. Everything is eligible, including, you know, even some of the advanced light water-based designs. The construction and demonstration of several advanced reactors are beneficial for inherent safety, lower waste, greater fuel utilization, secure reliability, proliferation resistance, improved thermal efficiency, and the ability to integrate both electrical and non-electrical applications. I think one of the interesting things about our solicitation is that since we are technology neutral, we really have tried to focus a little bit more on the commercial viability aspects of this. And that does bring up a lot of those questions of how do we address these codes and standards moving forward when you're in a technology neutral perspective. So there are 3 pathways under this financial opportunity announcement. The first one is the actual demonstrations. These are the closest to commercialization. The goal is to have them deployed within the 5 to 7 years of the award, and the initial allotments for the awards for this fiscal year are $80 million. However, that is just the initial investment. Congress and DOE anticipate, you know, the standard practice of the government, which is annual funding and moving forward. We do know that from that standpoint, Congress is very energized about this. They've directed it, and so we do expect to have that financial support moving forward to complete this program. The second area is the risk reduction for future demonstrations. the goal here is that we know that there are some reactor designs that aren't quite ready to demonstrate. And so they're a horizon where they're at least 5 years behind some of this other technology. And so we're looking at, 3 to 5 potential awards in there. We've got an initial allotment of $30 million to split between those awards and FY20 funds. But again, like the advanced reactor demonstrations, we expect that Congress will fully fund those efforts as well. And then finally, we've got the advanced reactor concepts, the ARC-20 awards. And these are designed really for those early entries, the challenging designs that are a little further out than some of the other ones. And they're looking at least 2 awards of $20 million. So there's a lot of other activities and capabilities supporting industry in the advanced reactor development. The National Reactor Innovation Center is there to help us, identify key gaps and barriers to enable developers to demonstrate reactor concepts. This area is located out at INL, but it is a cross-lab collaboration. It's supposed to provide an access point for those folks who want to work with multiple labs or need that support for finding a location to test. And it provides well-characterized locations to site reactors, access to key resources, and promote collaboration with laboratory experts in the nuclear science and engineering and support technology development. I think this is another one of those areas where buried in there is the intent to support our codes and standards work as well. And I think some of the folks here are aware of the Gateway for Accelerated Innovation in Nuclear, the GAIN initiative. This allows industry access to labs R&D infrastructure, and the goal is to achieve faster and more cost-effective deployment of innovative nuclear technologies towards commercial readiness. We got our nuclear and radiological test facilities, computation capabilities, information, and data through the Knowledge and Validation Center, and land use. And so these, although, as you'll see through some of this, codes and standards aren't directly called out. It is part and parcel to what we do, because we can't move these things forward into a deployment standpoint without both the community buy-in that the information is correct, that the industry has the capability of applying this research, and that our partners at the NRC have the ability to regulate and approve the design as well. The third area is our industry opportunities for advanced nuclear technology development. This is also known as the IFO, or the industry FOA. There's currently 3 application review cycles per year. These are competitive, cooperative agreements, and depending on what it is, if it's R&D or up and through demonstrations, the law requires that we have either 20 to up to 50% cost share contributions. And these projects are funding and aligned with R&D programs in the same goals as we see, but the pot is generally a little different and a little bit larger for the demonstration capabilities. And then there's the Advanced Small Reactor, Modular Reactor R&D program. This focuses on the cost share of private and public R&D partnerships to address technical and operational and regulatory challenges specific to the small modular reactor area. So when we start looking at the advanced reactors in general, we do understand that there are potential advantages. The construction timelines for the advanced designs are expected to be shorter than the current generation of light water reactors. These advanced designs will take advantage of the advanced manufacturing techniques and modular construction. Hands-on labor costs will hopefully be significantly reduced. Factory-based work-controlled environments versus field operations, and constantly adjusted to field conditions, increasing repeatability and quality, and reducing component inspection times and rejection rates. I think this is going to be an interesting area for us as we move forward in codes and standards, because what this indicates to me, especially within the digital design empire that we're living in, is that we have to be cognizant that especially with a lot of the advanced manufacturing techniques we're looking at, is that our quality control and our qualification processes are part and parcel to the build of the parts. And when we start looking forward and moving forward in the codes and standards, this is a new realm where we're going to have to accept and modify our thought processes in order to integrate those digital systems with our normal material standards and qualification processes. The simplicity of the designs reduces system component and complexity, reduced commodity and labor costs. You know, we have a lot of advantages coming out of the new manufacturing capabilities and techniques, but there's a lot of work on the backside as well to make sure that they're acceptable and to promote their use. So, you know, the importance of the codes and standards to advanced reactors. The standards provide the basis for efficiency, standardization of products, improve trade, commerce, safety, and quality objectives. They incorporate the evolving technical advantages and lessons learned from real-world use to ensure the standard continues to be relevant. And I think this is very important from a DOE standpoint of where we need to be coordinating much more closely with industry and our vendors. R&D is great. It starts us down a path where we can take advantage of those, but we need the experience of the hands-on work, the work of factories to feed back into these R&D structures, so that when we start developing the systems, we take into consideration the actual work on the ground of the production environment. You know, we set minimum requirements to protect our health, safety, and general welfare and affordability. And they set an understandable and reliable basis that reduces vulnerability to a wide range of hazards. And as I've been part of the advanced reactor community more recently, I see this last bullet as becoming a very, very important point that we need to remember. This serves as a common language, and it increases the interconnection between our industrial complex. And I say this because when we have individuals and we're off looking at our own individual designs, we end up developing our own internal acronyms. I have seen multiple organizations with the same acronym speaking across the table from one another, and we think we're saying the same thing, and we are not. This happens in safety cultures, this happens in engineering cultures, and even when we start looking at just the changes between our various industries, you know, be it, you know, petroleum or fossil fuels, and looking at the materials and applications that they're using over there, and trying to import those things into our nuclear realm. We have a lot to learn, and they have things to learn from us. You know, the extreme example I had for myself was when I was over at the Coast Guard. You know, coming from the nuclear realm and working with the national laboratories, we have a SAR, a safety analysis report. It's been common language for me for many, many years. I moved over to another group. SAR for them is search and rescue. And so it's just an awareness of when we have our language and these common interconnections within our industry, that be aware that sometimes we have to go back and revisit to make sure that we're all on the same page. So what is DOE's role in overall? You know, we provide the techno experts to working meetings and as coordinators. We're trying to accelerate the identification of gaps in the standards development process and the methods to close those gaps. We provide support for national standards. We support research and development activities needed for this, and we support the codes and standards and adoption process. The key here in a lot of this is that many of these times DOE is very much in a supporting role. And I know that we can provide the leadership in getting coordination and being coordination points. But from a consensus standard standpoint, especially when we're looking at being led by the industry and by the reactor-based community, we need to be in that supporting role, because we need to understand what are the priorities coming from our vendors. Where do we need to focus our resources? Where are we going to get the most benefit across our complex for our research dollars and the resources that we have available? And so, you know, I see DOE moving forward, especially like in the advanced manufacturing area, to taking much, much broader leadership within the coordination community aspect. You know, and so in summary, you know, DOE provides us sustained investments to support codes and standards development. Although it's not always directly called out, it is part of our inherent work that we need to do. And moving forward, I think, especially with like the advanced manufacturing area, you're going to see this becoming more of an important role called out directly. We integrate that with, the Advanced Reactor Demonstration Program, and this does provide us a very unique opportunity to advance the development and application of new standards. I'd say the challenge in that area being that we are developing the reactors nearly at the same time as that, or just slightly behind maybe, the actual standards. And so, as was mentioned earlier, I think one of the things that we need to consider when we look into this is our risk-based decision making. This can help guide us in how we're going to apply those standards and what kind of risk we're going to take forward to getting these new first reactors demonstrated in the field. And then finally, DOE's investments in our advanced manufacturing. We're trying to increase our stakeholder participation. This is industry. This is broadening our applicability to internal DOE offices, our standards folks, coordination with the NRC so that everybody is on board, that we all understand and have a mutual understanding of the standards going forward, and leveraging all of our technical expertise at the lab in order to promote these codes and standards and get them in place as quickly as possible. And with that, I'm happy to take any questions.
Great. Thanks so much. Mike, did you want to handle Q&A or?
Yeah, I'm looking through the queue of Q&As out here, but they don't necessarily seem to be specific. Here's one that is, I guess. So let me read it. And Dirk, I think you can probably see this too if you pull it up. It says, is the Standards Development Committee or Working Group wishes to request DOE funding to help support the development of a new standard or to maintain or update an existing standard, to whom at DOE should they direct their request for funding?
So I think that depends on what exactly we're looking for. Funding is very broad. And when we said, okay, we want to work on this, one of the things that we do have, is that we do have our own national technical directors. And part of their responsibility is to effectively work with the folks who are looking to update the code and standards. So part of this is ensuring that both the codes and standards that DOE needs to be working on are prioritized from the industry standpoint, and also that we are already coordinated enough where the labs may already be working on some of these activities, and we need to make sure that everyone is aware of them, and then decide how much funding is available at any given point in time. Because we both have our GAIN initiatives, we have our directed research that is part of, under the leadership of our national technical directors, and there are priorities as well, which are coordinated with headquarters.
So in
I don't
your
want
presentation,
to I don't want to answer it. I don't want to answer it directly because I think it depends on what the scope is. And I think part of that is understanding exactly what we need to do and to get an understanding of what we need to accomplish that goal. And so when it comes to who is the point of contact, I think right now I am the point of contact. We provide the information to me, and then I will get those folks in contact with the people in the field that are actually actively working on. Because we do have folks that work directly with the NRC and with, like I said, our national technical directors who are supposed to be part and parcel to the codes and standards work.
So thank you, appreciate that. The one thing that comes up, you mentioned in your presentation about the demonstration reactors, and it seems to me that that's a logical priority moving forward once those technologies are chosen, since they're the near-term projects that are going to be pursued, that may help make the vision more clear as to where the work needs to be focused. And I'm interested in what you think about that.
I think that's accurate. One of the things I think I will give you my personal perspective since I've joined just from the advanced manufacturing standpoint. When I look at the portfolio that we've seen from the National Science User Facilities, the GAIN initiatives, and our various other funding, is that we have a lot of good ideas and a lot of ways where we can do a lot of advanced manufacturing, a lot of very good work. But a clear prioritization or a consensus of where we need to apply those research, both on the methods for advanced manufacturing, it being laser powder bed fusion or the various other techniques, as well as the materials that we choose right now that are going to have the greatest impact to our near-term deployment is going to be critical. I don't necessarily see a lot of that with the way that our program is currently organized, and that is a push that I hope is going to be moving forward from our standpoint, from the DOE standpoint, as we march forward, realizing that we do have limited resources and we cannot do everything at once, so we do need to prioritize, especially if we want to get things deployed.
Okay, I have another question here. I think we have time for one or two more. It states that DOE has an agency-wide technical standards program which used to be sponsored by NE. Has any consideration been given to using the processes of that program to record standards needs and conduct the development, review, and publication of those standards first as DOE technical standards, and then work to transition those standards to the national standards community?
Oh, that's a really good question. And honestly, I have not been able to get myself fully apprised of all the standards work that DOE has done historically. I'm still a little bit new in both the standards development for the Reactor community and some of that, mostly because the work I was doing prior to the Coast Guard when I was working with NE in the space area is very niche, very specific. And so this is one of the areas that I need to get more educated on. And I think it's a very good idea, whether or not, if that's still being run by NE or through the Office of Science, and leveraging that community to bring, I think that's part of what I meant by saying we need to get the rest of DOE involved in the codes and standards as well.
Okay, so I think we have time for another question here. And the question is, how do we get feedback from DOE if a specific standard would be useful for DOE facilities?
Okay, can you repeat that question?
Sure. Is how do we get feedback from DOE if a specific standard would be useful for DOE facilities?
Huh. That's interesting. I have not, I mean, honestly, I would send the feedback to me directly. And I will provide my, at least my email and contact information to the ANS folks so that they can distribute it. I can't guarantee that I'm going to be able to answer everything, especially if everyone on who is participating starts emailing me. But I will try to make sure that it gets to the correct folks, because part of the things is DOE takes into consideration a lot of our other requirements, not just necessary specific DOE facilities, but across our complex. And so that when we develop internal standards and processes, they may not necessarily be applicable to broader community use. They can be very specific to DOE's requirements based on our legislation or other aspects that are inboard at DOE.
Okay, thank you. Well, thank you for your presentation. I think we're right on schedule to move on to the panel discussion that Mark Nickel is going to chair. So Mark, do you want to introduce the panel?
Yeah, let me get set up here. So thank you. Going into the next panel, let me talk about a little bit about the panel, and then I'll introduce the speakers. So the purpose of this panel is to hear from developers and get their perspectives on advanced reactor codes and standards, then their needs and how codes and standards fit within those needs broadly, and then more specifically their perspectives on sort of the challenges, opportunities, and next steps for advanced reactor codes and standards. So with that, we've got an excellent panel of speakers. We have a couple of speakers that actually represent technology working groups, so the chairs of the technology working groups, but they're also either developers or working very closely with the developers, and so they understand it from firsthand experiences as well. So without further ado, the speakers are Lauren Latham from Southern Company, also the chair of the Molten Salt Reactor Technology Working Group. We have Michael Cohen from TerraPower. We have Jordan Hageman from Kairos, and his colleague from Kairos is also the chair of the High Temperature Gas Technology Working Group. We have Alex Harkness from Westinghouse representing their eVinci design. And finally, we have Jake DeWitt from Oklo, who's also the chair of the Fast Reactor Technology Working Group. So within this panel, all of the speakers are going to go through their presentations, and then once everyone has made their presentation, we'll turn to Q&A. So as they go through their presentation, if you have a question, please type it in, and we'll get to it at the end of the panel. With that, we'll start with Lauren. If you could please turn on your webcam and unmute yourself, please.
Hey, can you hear me, Mark?
Yes, we can.
Okay, there's not an echo, is there?
Nope, you're doing great.
Okay, perfect. Let's see if I can share my screen here. Can you guys see my presentation?
Yes, it's up. You're in a you're in the format where you have the thumbnails to the left. I don't know if you want to put it in full screen or not. That's up to you.
Is it good now?
Yes.
Okay, perfect. Thanks, Mark. Yeah, thanks for the introduction. My name is Lauren Latham, and I do work for Southern Company, but here today to just speak more broadly in my role as the chair of the MSR TWIG. And really, what I wanted to cover was not a list of our priorities as a TWIG, but more take these few minutes to really talk about the approach that I think many of these vendors are going to take. I think that you're going to see different approaches from these vendors in the near term versus the long term of their deployment states. And a lot of that is due to the state of molten salt reactor technology. So most of these technologies have not been demonstrated, and none have been demonstrated at grid scale. Now, that's not to say that good engineering work isn't happening and we don't have a good idea about how to design, demonstrate, and deploy. But I do think that we're still in an exploratory space around determining best practice, which I think that codes and standards really represent that determination of best practice. So I think what you're going to see is a more practical near-term approach, since new codes and standards are not required to enable these demonstrations and deployments. I think that these vendors aren't going to put a huge emphasis on that effort in this near term. That's not to say that those new codes and standards are not desired by these vendors, though. And I think you'll see even some that have been worked on for a while now, like the non-LWR PRA standard, that we do want endorsement of in the near term, because they will help these vendors both in design and reduce regulatory uncertainty. So all of that said, to pose that I think the path forward is really to work closely together so that those near-term design-specific demonstrations can help lay the foundation for those long-term codes and standards to be developed. Because throughout this demonstration and deployment process, we will really determine what those best practices are. This slide just gives an overview of the members of the MSR TWIG, and I just wanted to put it on the screen really to tease out that there's a broad range of designs represented by the MSR twig. Of course, they are all liquid fueled, molten salt cooled reactors, but the difference in physics, the difference in reactor design, and even the difference in deployment timeline mean that the needs across the twig are decently broad. With that said, though, I do think that there is an opportunity for risk-informed, performance-based approaches to help everyone on the list. And that's something I think we've heard from each of the speakers, but just wanted to reinforce it here. And many of these vendors do directly engage with the SDOs by participating in committees or just directly providing that feedback. But the one thing I did want to offer is if, as a twig, there are any direct feedback mechanisms or prioritization efforts that we can help with from a more broad standpoint, then that invitation is open, and we look to directly collaborate in any way is most useful to the broader community. So Mark, I think that that covers all of the comments I wanted to make in advance of the Q&A.
Excellent. Thank you so much, Lauren. And so next we'll move on to Michael Kellen. Please turn on your webcam, unmute yourself, and share your screen.
Can you hear me okay?
We can hear you, yes. Are you able to turn on your webcam and put your presentation in full screen?
I will put my presentation in full screen. It's saying the host is not allowing me to start my video.
Okay, then Krista, could you please enable Michael's video?
Okay. All right, and then it's going to. Okay.
Great, thank you.
All right, and you can hear me okay, and all right, so we're good to go. Hi, my name is Mike Cohen. I am from TerraPower, located in Bellevue, Washington. And I want to give you some of our perspective on how we work with codes and standards committees. So first of all, if you're not familiar with us, we have two technologies that we're working on that come under this category. We have our sodium fast reactor, the traveling wave reactor. So it's a sodium cooled reactor. And then we also have a molten salt reactor design that Lauren just mentioned. That's our molten chloride fast reactor. And both of these are considered advanced reactors, and in ASME terms come under the high temperature reactor code. So just to give you an overview of what we're currently involved in, we have membership on ASCE committees, that's the DANS committees, or ASCE 4 or 43 that you may be familiar with. And then in ASME, we're heavily involved mostly in Section 3 and in particular Division 5, which is high temperature reactors. And then we're also involved in the probabilistic methods and design. And then there's a new committee, Standards Committee on Plant Systems Design, that we're involved with that as well. We don't have membership on Section 11, but that's one that's important to us also. And then also in ANS, there's the performance requirements or probabilistic-based design for the molten salt reactors that Lauren mentioned. And then we also have involvement in the EPRI Advanced Reactors program, and then numerous IEEE codes and standards that are related to instrumentation and control. So kind of some of the important issues for us are And I think Lauren's slide really kind of nailed this, talking about the short term and the long term and the practical versus the optimized. So frequently we adapt designs because the time to implement them in the codes and standards dictates what are available and what they aren't. And so I guess I'd pose the question to the community is does this make sense to do things this way? So for example, the great example with Section 3, Division 5 in ASME is that currently we just have 6 materials approved for the high temperature code for the Class A components, and people will come to us within the company and say, can I use this material, that material? And we say, well, it depends on when you're wanting to be able to use it, and it depends on how much data you have and so forth. And then there are other potential workarounds where maybe we used an approved material as the base material, but we could clad it with some other kind of material that would give us a more of the chemical interactions or not interactions that we're looking for. So, and then moving on, as far as the issues go, a lot of the time we've spent is kind of laying the groundwork for how we get involved with consensus-based committees. So we do have active membership on a lot of them. And I think the key takeaway here is that it's not a trivial effort. You know, the meetings are frequent, 4 times a year, but the more involved you get, the more time commitment that takes. And so I think TerraPower has been very supportive of that. But what we do is we help work on their backlog of items that the committees are working on from us or mostly from other people, or just kind of historical kind of cleanup work. And we help provide input, and then we help kind of prioritize things as far as our needs goes. But it's actually very helpful to be involved in that way because we understand what the issues are. We kind of understand how to work things, how things work, and how we can get things done in that existing structure. And then some of the newer things that we're involved in, such as the plant systems designed and the ANS standard I mentioned, we've been involved in since the beginning of them. And for a couple of reasons, we know that it takes a long time to get this stuff done, but also we can help influence them and steer them to take our designs into consideration. And then another important issue for us is, will the regulator accept the new rules and revisions that we're involved with? And, you know, there's this additional step. It's getting things into the code and standard, and then having the regulators' feedback or endorsement or whatever we're looking for there for that. So the question was posed to us, what are our urgent codes and standards? So we are, I guess what I'd say is our involvement, the ones we're involved in that I showed you on that earlier slide, are the ones we've deemed to be urgent to us. Mainly what we at TerraPower focused on our codes and standards that affect the nuclear island, because that's, you know, we're focusing on the design of the reactor itself and the immediate structures and components supporting that. And then of course we would partner with other people who would help possibly be interested in other things too that maybe we even have a blind spot to right now. So something like ACI that was mentioned earlier. Of course, we're using codes and standards that are recognized by our regulators. We have looked at other international standards to kind of see what's available there, but right now we're focusing on things, well, the ones I showed earlier. And then again, time also factors into which ones we're actively involved in. So kind of playing that long game, as Lauren mentioned, we look at the short term, but we also look at the long term as well. So some kind of more specific areas of interest, although I guess I don't get too specific here, things like when we do our safety analysis, things that are related to safety related equipment. And of course, in advanced reactors, you could start off by assuming that's very similar to LWRs, but we really want to take advantage of some of the safety features, and we want that to be reflected in the codes and standards. So as I'll show in a upcoming slide, that can be reflected in cost. Another interesting thing that someone else at TerraPower brought up when I put the slides together was the supply chain may need changes for long lead items. And so it's not just helping us designers, but helping the supply chain too get everything in a row. And then, of course, materials always come up as the example. And then I think I've already heard a couple reference to risk-informed approaches, and that's in numerous codes and standards that we're working on. And again, that helps us take advantage of some knowledge to help reduce cost. So yeah, so potential benefits under a couple categories. So design, using new materials, methods, and rules helps give us more design options, and then in the future help have more optimized designs. Benefits as far as licensing go, we don't necessarily feel like we need the changes to facilitate licensing, but of course we want to keep the regulator involved so that they're not caught off by guard by anything we come up with or anything we're doing. Otherwise we could face licensing delays. And of course we want to engage the regulator with things like pre-application interactions and so forth to keep them involved. As far as benefits go with respect to construction, for advanced reactors, we want to take advantage of the way we classify things with respect to safety, which could result in reduction of cost in terms of things like inspection or quality insurance, especially if we can maybe almost downgrade the type of classification a component is in. And then if we can help streamline things to reduce cost. And then another issue is making it easier for suppliers to maintain certification. I think that came up in ASME interaction, and probably you'll hear about that later today. And then of course, under O&M, operation and maintenance, we think we can reduce some operational costs by taking advantage of advanced reactor features and streamlining the rules for advanced reactors, such as risk-informed in-service inspection. And then what is our timeline? Again, I wish I would have gone to that kind of near-term, long-term categorization, but if we want to think, and in some ways they kind of blend almost, because some of these long-term gains, well, if we're talking about our design operating in 2028, for example, then we probably need to have some things in there in 2 or 3 years. So I guess that's more the short term. And then we are heavily involved in things so that we don't have to ramp up and understand the rules of engagement at the nth hour. We can figure that out now and have people in the right place. But of course, you know, we've sort of followed the status quo about how we want to interact with codes and standards and get things done. But if there are ways to do things faster, we would definitely be interested in doing so. And that's all I have.
Great, thank you, Michael. Next up, we'll turn to Jordan Hageman. If you could please unmute yourself. Yep, thank you, and show your video and upload your slides.
All right, let me get started with just give me 1 second to get up. So my name is Jordan Hageman. I'm coming from Kairos Power. I'm getting my slide up right now. Share this screen here. So good morning. Thanks for giving me the opportunity to speak to you today. I'm coming from Kairos Power. We are a company in the San Francisco Bay Area. We are dedicated towards commercializing a fluoride salt-cooled high-temperature reactor that employs the safety case associated with retention inside TRISO fuel, the radionuclide retention of our molten fly salt, and the inherent safety of a low pressure system. So this is a picture of 100 of my closest friends. This is Kairos back in maybe 6 months ago was 100 people strong. We're now at around 140 employees, and we're very active in our pre-application engagement for our FHR technology with NRC. This slide has our mission statement, where we try to start every meeting internal to Kairos with this mission statement. Kairos Power's mission is to enable the world's transition to clean energy with the ultimate goal of dramatically improving people's quality of life while protecting the environment. This mission is sufficiently broad that I think all of the participants on today's panel should be able to say that they are working towards some version of this. And I like to start out meetings with this mission statement to focus on the word enable. And I think that that's what we're here to do with the NEI workshop today, is to enable the transition to clean energy with a variety of technology vendors that have ideas of how to do that. So pertinent to today's panel, we were asked to look at the standards and to give priority, give an idea of where the vendor priorities are and where they're not. So I'm using the NEI 1903 document that we heard about this morning as a list of what are the standards that are out there. And we are, on the left here, we have a list of standards from that document that we consider to be important, mission critical to what we're trying to do. They go as broad as the non-LWR PRA standard, which has become very important to our licensing case, to Section 3 Div 5. There was a note in there about developing the equivalent of QME1 for passive equipment. So standard on safety-related instrument lines, and then of course Section 11. So the standards that we consider to be high priority, taking a look at the list, I observed that they're all based on technically heavy standards, technically heavy topics where a lot of research and development is needed to ensure that we are developing an adequate product, and it gets very, very specific research-based areas. Compare that to the list of standards where Kairos is not seeing a lot of value from the ideas of the standards. So the first on the list is actually, it was one that was in 1903, and it was marked appropriately as non-applicable because the standard's already been discontinued. This is the design criteria for FHRs. And what happened there is we realized that there was only one FHR vendor in the field, and the ideas in that standard were better off in the hands of a vendor that is active in their pre-application engagement. And a lot of those ideas we took and we ran with, and you can see now Kairos has submitted the topical report to NRC with our principal design criteria. And that gave us the flexibility to look at what we wanted to commit to in terms of design criteria and offer an initial set. There's some other activities out there, ANS 30.1 and 30.2. I'll talk about them together because in our mind, there's significant overlap between what these standards seek to do and accomplishments that have been made this year by the industry-led licensing modernization project. The LMP project put out 2 revisions of NEI 1804. Very recently, it got endorsed by NRC in Reg Guide 1.233. And we, as a vendor in pre-application engagement, we are focused on taking that NEI 1804 process and figuring out how a vendor is going to implement a risk-informed performance-based strategy of licensing. And we are very happy that industry was able to come together and put together this document and get an endorsement from the regulator. And we think that that is sufficient for now. And now's the time for vendors to go off and start to innovate in the space, figure out what is the right way for their specific organizations to go in and implement an 1804 style process, develop their safety case, and actually develop a state of practice going from a blank sheet of paper to a baseline design. And we don't actually see this as an area where we need further standards out there or further statements written that could potentially cause confusion when we've already developed a consensus in 1804. So taking these two lists, we identified that there are some risks and opportunities generally in new standards, and I wanted to talk about each risk balanced with an opportunity. So the first risk that we see is, like we were talking about in the last slide, developing standards on topics where there might be overlap or conflict with ongoing regulatory engagement. And outside of seeking early alignment with vendor priorities, one potential opportunity is to just across the board start saying, if you have a brand new standard, a TUPA process is probably a good idea, a trial use pilot application process. We had a lot of success with this with the non-LWR PRA standard, where it was put out in 2013 and it was exercised by a number of vendors. And feedback was given on what do we need to make this standard work with all of our other licensing or design or other safety case priorities. There's the second risk, developing standards on topics before a state of practice is actually established. As Lauren said earlier, we're really in exploratory space, and we want enough room to innovate inside the space, figure out what works, what doesn't work, and once a vendor reaches the finish line in terms of a design certification or a new plant build, that's the time to go back and say, okay, what's the best practice coming out of this? What are the opportunities to standardize? But we don't want to get ahead of that. So we think the opportunity is to focus our resources on technical research-heavy topics supported by a state of practice. And then the last risk, and then I'll yield the floor, is tying up limited resources from the labs, from the vendors, from the rest of the industry on efforts if vendors have stated that there's not clear value there. And the carrot end of this, the opportunity is if there's good alignment between vendor priorities and the mission of a standard, you are going to attract vendor participation. The prime example of this is we are balloting the non-LWR PRA standard right now, and Kairos is providing a large number of resources to actually implement the work, to go through the 1,300 comments and resolve them, because it is so integral to our ongoing priorities. So let me stop my share here. I know we have a lot of participants in this panel, so I look forward to hearing the questions when they come in. Thank you.
Great, thank you, Jordan. Next up, we have Alex Harkness. If you could turn on your webcam, unmute yourself, and share your screen, please.
Thanks, Mark. Can you hear me?
We can hear you, yes.
Yeah, I currently don't have video capability, so I can share my screen.
That's fine. Yep. Do you have a presentation to share?
I do. Can you see? Oh, wait a minute. I got to hit share. All right.
Not yet. There, it's up. Thank you. Go ahead.
Okay. Thank you. Good morning, everyone. Thanks for joining today. My name's Alex Harkness. I'm the Chief Engineer on the Westinghouse eVinci Micro Reactor Development Project. And today I'm going to give a very high level overview of our technology and some thoughts we have with respect to the development of codes and standards as they apply. Now, advance my slides. For the Vinci microreactor, we're trying to pay attention to the market requirements. For this particular application, the key driving requirement is the transportability of the device. We're working to incorporate the entire reactor into standard shipping container envelopes. Ease of operations for remote applications are pushing us towards an autonomous control concept. The battery concept, where we're not doing refueling, remote refueling in remote places, but the entire reactor is shipped back to a refueling facility. Adaptability of the design, our customers are looking for heat and power applications. We also have flexibility in the use of fuel, so we can use different types of fuels in the reactor. And for a commercial company, we're very driven by the economics. We want to be competitive with other existing power sources. So our technology is heat pipe based, so we don't have primary coolant like we have in today's reactors, but we have heat pipes that are transporting heat from the core to the primary heat exchanger. This is not, as I think Mark and others have mentioned, these technologies have been around for a while. Westinghouse actually worked on this technology in the early 70s, but it was limited at the time by the capability of heat pipe technology. Over the last, what's it been, 50 years now, heat pipe technology has come a long way, and Westinghouse looks to exploit that in our design. So the target power for our unit here is around 2 megawatts electric, but we can also do larger designs based on the facilities. Full factory built, fueled, and assembled. So at site we would be essentially installing the reactor. 40-year design life with 3 years of continuous power. So after 3 years, we look to refurbish the core and continue operating throughout the life of the plant. Inherent safety, we have no operator action or mechanical actuations required to shut down the reactor. Capable of providing high temperature process heat, which I'll talk about in slides coming up. A zero emergency planning zone, and a small installation footprint. So the basic design, what kind of sets it apart is it has a monolithic core. It's a solid core with the heat pipes penetrating with fuel channels adjacent to the heat pipes. We're using sodium heat pipes, and we have high temperature operation. So on the left here, you can see, or lower left, you can see a overall assembly of the reactor. All the primary components are contained within a single shipping container within the canister that you see surrounding the components there. Just to the right and a little bit higher, we have a cross-section of the core. You can see in our design we have control drums, shutdown rods that are depicted by the circles around the outside. These are the control drums, and the shutdown rods are internal to the core. So the primary means of controlling the reaction is the control drums, and the shutdown rods are provided for situations where there's a fault in the control drums. Here's what a fixed installation might look like. So whenever we have the ability to do on-site construction, we would install the canister itself within a vault constructed on site. This is our team, Westinghouse, Los Alamos, Idaho National Laboratory, Southern Company, and the University of Pittsburgh are all working together on designing this reactor. So as far as the development landscape and how it might apply to the codes and standards, So there's some significant things to pay attention to, differences in microreactors and the approach for the development of microreactors. The most significant, I think, is the shift in deployment models, the factory built, site installed. Today's standards and regulations are driven by more traditional build cycles and schedules. We have the ability to do full-scale technology demonstrations. It's not only possible, but it's expected and anticipated and currently being planned. We have aggressive development timelines, demos by 2024, current target. High temperature components and materials are key. For us, our core design temperature, or average operating temperature, is 800 degrees C. And we have core temperatures well above that during normal operation. So shared technology with today's larger nuclear power plants is very limited. So there's very little to start from with respect to the overall plant design. Applicable operational experience is also very limited. I think it was also pointed out already that the technologies being developed are very diverse. So that kind of draws into question how widely applicable a standard would be if the technologies are very diverse. Licensing approach for these reactors, for advanced reactors, is shifting from today's approach to a more performance and consequence-based approach. And one thing that's, kind of weighs on me a bit, since our designs are continuing to mature, what is very important to me today may in a couple of months not be very important at all based on the work that we're doing. So these are challenging challenges that are presenting us with a lot of opportunities, especially in the area of codes and standards. So what are we doing today? So existing codes and standards are being referenced where applicable, or when the underlying principles are thought to be broadly applicable to the new technology. So we have codes and standards that have been developed for other applications, but the underlying reasons or basis of those codes are still broadly applicable. We will use them. Our gaps have been identified, and a strategy to address each is under development. I think Lauren mentioned that we don't need codes and standards to develop these demonstration projects, but the demonstration projects ultimately may form the basis for a code or standard going forward. General concerns, the ability of codes and standards bodies to respond to development or aggressive development timelines is a concern. Limited applicability due to design diversity draws into question the need for industry codes and standards for these types of reactors. And I'm very interested in what role the codes and standard bodies will play in the licensing of advanced reactor technologies as we progress our designs. And that's what I have to share today. If you have interest in more information on the Vinci microreactor, you can go to our website and or contact me directly.
Great, thank you so much, Alex. Let's move on to our last speaker, Jake DeWitt from Oklo. If you could, thank you, unmute yourself, turn on your video, and share your screen, please.
Thanks, Mark. And thanks, everyone. Appreciate you guys having this conversation and putting this together. I think it's a a good time to be kind of visiting these topics as the advanced reactor industry is maturing and moving further and further afield and closer to actually building and deploying technology. So happy to be here today. Some of the comments I'm going to have are going to echo some things you've already heard. I think there's pretty consistent alignment across a number of developers in terms of different areas of interest, what's priority, what's not, and the general philosophy about how codes and standards make sense. So just quick introduction, I'm Jacob DeWitt, CEO and co-founder of Oklo, as well as chair of the Fast Reactor Working Group. The Fast Reactor Working Group consists of a pretty cool set of developers, if you think about it, pursuing basically an array of technologies. We span everything from sodium fast reactors to lead fast reactor development to gas fast reactors to molten salt reactors. To give you an idea of the numbers, there's 4 groups pursuing sodium fast reactor type technologies, 3 with lead fast reactors, 1 on gas fast reactors, and 3 on molten salt fast reactors. So what I'll be talking about today, to a degree, highlights some kind of things that are, I would say, generally speaking, agreed upon. There's some specific cases and specific examples that I'll highlight in some cases, and in other cases, there's obviously interest in things a little bit differently across each vendor's pursuits. Some of the molten salt specific things I defer to what Lauren mentioned earlier, specifically with regards to that design standard being developed. That said, I think one of the interesting things is that's going on, obviously, is advanced reactor technologies are maturing and going forward. At Oklo, we're the first non-LWR to have a COLA under review. We're excited to have submitted that, to receive acceptance for that. We're looking forward to that progressing and are definitely learning things. And I think one of the things we're observing with advanced reactors is it's very important to be pioneering new things and new ways of thinking in general that will help us, I think, be successful in terms of how we're looking at this. And that extends to a degree too, as well, for certain aspects of advanced reactor codes and standards development and how we think about that. Another aspect I think is kind of valuable to talk about as we kind of paint this picture and understand this landscape is that advanced reactors have been and are en route to being demonstrated sort of as independent, if you will, of the Advanced Reactor Demonstration Program. I think that's a very important program for the country, but also some groups are doing that on their own with private funding or by other means. So I think that kind of reflects the opportunity for nuclear in front of us, but also the array of things in terms of business models and development strategies that are being pursued and approached. So that's, I think, an encouraging and heartening thing to keep in mind. I highlight that just to make sure folks understand things are occurring and will be occurring independent of how the ARDP goes forward, which shows kind of the resiliency of the advanced reactor ecosystem to me. So jumping into this, I think, when this workshop was brought up and a conversation that's been going on over the course of the last few years inside of different aspects of the advanced reactor industry, and one thing we've seen at Oklo and have had conversations with some of the other fast reactor developers is as you look at what's going on, one of the key things is not just around the technology development, but also new design, development, and deployment models, then kind of the, I would say, legacy of what the industry's done. And I think that's pretty important because it's modernizing a lot of practices. And I think one of the things that falls out from those conversations are how we look at standards and understand them. And I use standards as kind of a colloquial term to lump standards and codes together. So standards are very valuable resources and tools effectively that can enable industrial activities. But it's important to keep in mind that they're not absolutely required or as prerequisites for everything that's going on. So that means we should maximize their utilization and where they're most effective and focus those development efforts accordingly. And they really make sense to develop and adopt when an industry is thriving and growing. In other words, after experience has been gained from kind of first of a kind or early demonstration or deployment efforts. That's a theme you've heard from multiple developers here. I think that's important because those practices and those experiences tie over. On our team, we have experience from folks in the automotive industry, and it's interesting kind of comparing how things are done in that space and how things are thought about, and trying to draw that similar kind of mentality over to nuclear, I think will be helpful, especially as we look at what I think is a pretty bright future for the technology. And so as a result, standard development should reflect industry activities and priorities in the way that they're most useful for everyone involved. I think there's some good comments made earlier about how they provide basically a resource and a tool that both help with technology development, regulatory approaches and licensing, as well as the supply chain and supply chain management and development. So as I mentioned, couple key considerations that I think are important, especially as standard development organizations engage here, is standards should reflect industry's priorities. That's, I think, a critically important aspect of what's going on. That's obviously reflected by organizations engaging in standards development, but also just getting feedback from from organizations like it's happening today. I think that's an important aspect to help guide and reflect what's actually of value and what's of not. I think it's also important that we think about standards being developed after state of practice has been established. I think that's a very articulate way of saying that, you know, some work should be done so that standards are not poorly defined or poorly developed, or ill-defined or ill-developed. In other words, we're not painting ourselves into corners prematurely, but rather getting the most out of our work and getting very productive standards in. It should also be mindful of ongoing activities. So conflicts should be avoided, ideally, where it could present challenges. In other words, you know, one aspect that I think is of interest here is while standards are voluntary use, once they become adopted and deployed, especially in the regulatory environment, they become expected in many cases, introducing, in some cases, more work than not to explain why you may not be using them. So I think it's important to keep that kind of in mind, that yes, they're voluntary, but also understanding what the differences between voluntary and expectation is. Also, I think it's important, this is something Jordan brought up, and I think it's very important as well, the idea that standards should be focusing on research and development approaches. In other words, they're very useful for technologically based approaches to things, not necessarily processes. In other words, you'll see us kind of defer interest and deflect interest on things relating to design standards and things like that that go around, you know, the actual design process, not seeing the value that that necessarily adds. And in fact, adds negative value in some cases, I think. And similarly, as we think about all these things, that helps, I think, organizations prioritize resources in ways that best reflect what's needed. I think in the reality of things, as we're seeing what's occurring, there are some clear cases where standards development is prioritized, which I'll get to in a second. And in some other cases, it's not so, you know, prioritized. And I think that should hopefully help standards development organizations see what's happening. And over time, that's going to grow. Over time, as these technologies mature and the advanced reactor industry grows and matures, there's going to be obviously a significant demand curve to get standards going. And I think it's understood that there's a time lag there, but I think that's expected because we know that that's what the reality is. I think people are working around and through that and expect that standards will then be better defined and better informed coming into play at the right timing. So, you know, it's always good to have an eye on the horizon. And I think it's important to have these conversations because that helps, I think, identify these things. And it's good to frequently update these conversations. I know this is, you know, been a repeating theme of a workshop. It's good that this is happening again this year. And I think one thing that I think is a really useful way of exploring standard applicability, especially in the early cases of standards or where perhaps standards are being initially deployed, is looking at trial use pilot applications. You know, the quote unquote TUPA part or approach can be very useful in at least working through the kinks, if you will, and also ironing out those details in a standard to make it most useful. Also in broad strokes, materials related standards and codes are, I think, very important. I think there's generally speaking broad support. Obviously that is kind of paying lip service to something that may be somewhat obvious. You know, there's also an understanding it takes time and resources to do that. I think the national laboratories, the different developers, the academic community, I think all realize that there's different priorities and opportunities in regards to the development of codes and materials, or codes and standards for new materials, and that can pay a lot of dividends going forward. And so, you know, as we look at that, it's good to be visiting those, prioritizing what can be done there with acknowledgement and understanding of where those resources are limited, and ideally pull more resources into play to do that. I think another question that is brought up sometimes in the community, the developer community, is how can we potentially revisit, if you will, or modernize the development of codes and standards to be more applicable in some cases, as well as to be quicker to be developed. What I mean by that is, are there chances or are there ways that we can think about the actual codes and standards development processes and revisit some of those in light of modern technology advancements? I know there's things that go on around that space. I think it's a question, especially on the materials side, that can be somewhat opaque to a number of folks. And so I think just to plant that seed, you know, as much as we can think about how possibly we can accelerate that development, especially on the material side, or find more efficiency so that it can be done more cost efficiently. I think that's a useful activity to just frequently revisit so that we're not necessarily carrying on old practices that perhaps could be improved or modernized. And I think in general, perspectives on codes and standards activities, with regard to, this kind of is a brief list. It echoes what you saw from Jordan. It's very similar in terms of a list of things that matter and kind of have been discussed amongst different fast reactor developers of having priority and ones that don't really have priority. Obviously, the boiling pressure vessel codes have a decent high degree of priority given their applicability across different designs, as well as the importance that they have to advanced reactors. So you see here section 3 div 5, section 11 div 2, section 3 div 1 and div 2 are kind of ones that stick out. There's also interest in the equivalent QME1 for qualification of passive equipment, and then as well as the non-LWR PRA standard. There's some other codes and standards from the NEI document that I think have some degree of interest as well, but these were the ones that kind of have I'd say the highest priority that was identified. Again, though, there are others that do have some degree of interest in prioritization. That said, I don't think there's much interest, frankly, at all in ANS 30.1 and ANS 30.2. We feel like those are somewhat either antiquated or out of date or not aligned with what the industry is really doing right now, and do present some actual risk in the sense that it could slow down activities and it could reduce the diversity of innovation that's going on. I know that word sometimes can be overused in nuclear, but the reality is there are some really new activities and new ways of thinking that need to be cultured and cultivated and allowed to actually grow and test things and iterate and either succeed or fail. That will inform better approaches in terms of process-oriented, considerations with how you design reactors, how you think about those things. And so I think that's a pretty important thing to keep in mind. So again, at the highest level, I think codes and standards obviously play an important role. We have to make sure we're matching priorities and such with them and how that actually fits together. So, so thank you for everyone's time, and look forward to the Q&A parts.
Great, thanks, Jake. And if I could ask all the panelists to go off mute and turn your webcams on. Alex, I know you don't have a webcam, but if you have a webcam, as I ask the questions and you're interested in answering, raise your hand so I'll be able to see that and call on you. So I want to start with, I think is the most provocative question that we received, because that always makes things more interesting. And the question is, if the designer needs the freedom to develop the technology, then does it make sense to expend significant effort in developing advanced reactor standards at this time, given that it may limit the possible technology, or the new standard may end up not being what needed should technology sort of take a different path? And I do think that many of you answered that question, and sort of what I sense from that is that in some cases it doesn't make sense to move forward for a standard. I think Jordan and Jake, you both had a list of high priority, which those are standards it does make sense to work on, and sort of given reasons why. And so that's the question. Hold it for a second, because I want to combine it with a second question, which is, if you're designing or developing your technologies outside the envelope of a code and standard, so within these areas where you would not advocate for developing a code and standard right now, then how are you preparing to address this with the NRC? So it's sort of a combined question you can ask. You can answer either part as you want. I see, Jordan, you're flagging me down, so let's start with you.
So I can address the second one first. Take the example of ANS 30.2, which is about the classification of the safety classification for SSEs. Our regulatory position will be based on Reg Guide 1.233, and which endorsed NEI 1804, which lays out how do you create a safety case that validates your selection of safety-related SSEs, non-safety, and then that middle ground, non-safety related with special treatment. So the groundwork is already laid, and it's just about getting to the details. And that's not necessarily an activity that needs to be governed by a separate standard. We've already agreed on the rules. Now let us figure out what's the most efficient way for Kairos to figure out how to do it. What's the most efficient way for Oklo or Westinghouse or GE to figure it out? And if we get to a state of practice that makes sense for everyone to share, that might be a time to evaluate, okay, should we pull 30.2 off the shelf and figure out based on the best practices, what's a good state of practice to codify in the standard.
All right, great, thanks. Anybody else want to offer perspective? Okay, let's move. I think those were good answers, and so let's move on to the next question.
Mark, could I just say one thing on this?
Absolutely.
So just, I'm not here to defend what was in the NEI report at all, because I wouldn't claim that we got it all right. It was an attempt to try to gain some clarity, but one of the reasons we put ANS 30.1 and 30.2 in there as a high priority is that when we worked with the people who developed the LMP process, what was in NEI 1804 was considered to be high-level guidance, and the details of how to go about doing things were going to be provided by subsequent guidance. So I kind of understand the picture as it's evolving is that people really can't wait for those other details to evolve through the development of ANS 30.1 and 30.2. They're doing it on their own right now as a matter of need. So I think that the shift of all the priorities here, or them not being a priority, is kind of a function of where we are in timing of everything.
Mm-hmm. Mm-hmm. Absolutely, yeah,
so,
and things evolve.
So that's a good point, Mike. The timeline is certainly a consideration, but there's also value in having the stakeholders actually chart the path forward and look at ways to innovate, because the stakeholders have the same organization that is defending something in licensing space and the same organization that's performing work, and the alignments are set up for the stakeholders to sort of figure out what those details are, rather than an outside organization that may inadvertently box in the stakeholders because they don't have all the sensitivities necessarily.
Great, thanks. Let me turn to another question. So this is an interesting one that's come up before, but I don't think really came up in the prepared remarks. So advanced reactor developers are obviously interested in exporting your technology, at least eventually, and differences in codes and standards between the U.S. and the countries you want to export to can have an impact on how efficient that is. So the question is, I'm going to modify the question, but you know, what do you see as the sort of need, role for harmonizing codes and standards internationally? And the specific question here is, you know, is there a need to work with ISO Technical Committee 85 and their Subcommittee 6 on reactor technologies, or, you know, just broadly anywhere, a need to work internationally so that the codes and standards you develop your designs to be licensed and operate in the United States are the same codes and standards that you're going to need to meet in other countries? Anybody have a thought on that?
Hey, Mark, it's Jake. I think that's a good point. I mean, it's a good question and it's a good topic of conversation. And I think that's an area of interest. I think in broad strokes, I think, you know, I think a lot of us are probably focused kind of in the near term aspects of getting something out the door. So I think this is something that's good to keep on the horizon. I do think as a broad perspective, as we think about how we interface with the international community in terms of also how we not just deploy, but also interface with their supply chains, it's going to be useful to, I think about, you know, more and more accelerated adoption and development using kind of international standards, frankly, as much as possible, or at least starting to think about how you tie some of those together. You know, those are pretty similar in a lot of cases for how they manage different aspects of the supply chain that we already think about, right? And there's a lot of work that's already happened in other industries. So I think if anything, one of the most useful things would be finding that efficiency in terms of how this ties into other work that's happened and try to chart that path relatively efficiently. But I think beyond that, the level of depth, at least on our side, would say, you know, it's of interest and importance, but we haven't really made much headway into those areas.
Mm-hmm. Yeah. Yeah, absolutely. I agree with you. And it's never too early to think about that. I'll just mention, if people are aware, of Department of Commerce has a US-EU SMR public-private partnership, and one of the work streams that they're focused on is standards and regulatory harmonization. So, yeah, it is something that is not too early to think about. All right, not hearing anybody else wanting to answer that. I'll move to the last question. I know we're a minute over, but I think this is a good question, which is something I hadn't thought about either. So there's a lot of discussion, and obviously the panel is developers or representing developer perspectives. But what about the role of equipment manufacturers, pumps, valves, vessels, et cetera? So what is the role that they have currently today? What is your interaction with them to help develop codes and standards where their input would be valuable? And the question just got lost on my screen. And is there anything we need to do to help coordinate a little bit more closely with them than we are currently today?
Hi, this is
yes,
Mike. I can take this one. I guess what I've noticed just being at ASME Code Week is that there are a fair number of vendors there, but in the codes that apply to advanced reactors, certainly less so. And I don't think we at TerraPower have specifically engaged suppliers to say you should be involved in this code and standard, but it's probably a good idea. Others, I will say there have been some that proactively do show up and have got involved, and I'd say more on their onus have decided to get involved in that way, but maybe there should be a more concerted or explicit effort to get them involved.
Great, thanks. Anybody else have a thought?
Mark, this is Alex. I just wanted to say that one of the benefits of the technology that we're looking at is that we don't rely on pumps and valves. So it kind of is taking that some of that element out of the development itself. So I just wanted to share that from our perspective, there's not a lot of value there for our particular design. Thanks.
All right, great. Lauren, I saw you try to maneuver. Did you want to provide a perspective?
Yeah, I mean, it's similar maybe to the first one. Some of the programs are taking an approach of very early engagement with a lot of the supply chain, especially on key components. Namely, the MCFR program within TerraPower, I think, is doing a really good job of this. You see them looking across the industry to make these key partnerships with experts in each of those fields and bring them along the way. But from the broader MSR community, you see a lot of supply chain development that I think that we're starting to have those key conversations now so that we're ready when demonstration and deployment comes.
Excellent.
Yeah,
Thank you.
Echo what Lauren said, Mark, because I think that's a really important point. I think that's one of the cool things going on is some developers are engaging at different levels, kind of according to their different plans. And I think that's really critical because at the end of the day, it helps map out what matters, but it also, I think, really importantly helps diversify the supply chain, which is, I think, one of the key attributes that advanced reactors can benefit from to that overall reduce costs and bring more innovative thinking and better thinking into the field to get, honestly, better parts made for these different designs that can utilize some of those technological advancements. So yeah, I think that's a important thing that is occurring and people are evaluating and trying to make the most of.
All right. Excellent. Well, thank you very much to all the panelists. Really appreciate all your remarks. I think I learned a lot, certainly, and I think this is going to help provide a good basis for the future panels as we move into the afternoon session. With that, I don't know, Pat or John, if you had some instructions as we plan to break for lunch, and we'll then come back for the next panel at 1.
Yeah, I'm keeping the webinar open, so it is personal preference. If you want to log off and come back, your link will work. The session will be in progress. So choose your preference, I guess. Oh, sorry. Mark, were you able to hear me? This is Pat.
We were able to hear you.
Okay, thank you.
Pat, this is Krista. We're just coming back at 1 o'clock.
Yes, and I'm throwing up the slide that does have the agenda, and I'm doing that right now.
Cool.
They got that last night at 10. So, Stephen and Mike are just, so I'm, okay. No, actually, I don't know. I was just going to check and see if it was muted. You're not on mute. You're not on mute.